So everybody knows, I think, that molecules are these really tiny, tiny things. So have you ever wondered how it is that chemists are able to determine exactly what's in these compounds, and how do they know what ratios you have in different compounds? Like, for example, how do they know water is H2O, or that sugar is composed of certain things in certain ratios? Well, one way that they do that is to determine something called the empirical formula. And there are a number of ways that you can do this. This is just the first example, probably the most straightforward example of how an empirical formula can be determined by doing an experiment. So we're going to look at an experiment that we saw in class, which is the decomposition of mercury oxide into its elements, mercury and oxygen. This is a pretty significant reaction from a number of standpoints. First of all, it's a really dramatic experiment to see. You start out with this orangey red compound and you heat it up and it turns into silvery mercury, and a mysterious clear gas is released which causes stuff to catch on fire. So you can imagine the first time that anybody saw that, they were probably pretty amazed. A guy by the name of Lavoisier was one of the first to study this reaction in detail. Lavoisier is considered by many to be perhaps the father of modern day chemistry. He was able to show that a particular gas, in this case the oxygen, was produced by this reaction, and he was able to disprove some ideas that were floating around out there at the time, which, quite frankly, were just wrong. So it's pretty neat stuff. If you have a chance, check out the reaction online, and maybe if you have time, read about Lavoisier. He had a pretty interesting life. But in any case, let's get back to the problem. So imagine that we weigh out the amount of mercury oxide really carefully, and then when we're done with the reaction, we also are able to weigh the mercury that we have after the reaction. And so we can start out with the mercury in your test tube, the mercury oxide, and that's heated up, and it'll break down into your mercury, which is a liquid here, and it will remain in the test tube. The oxygen goes away into the air, so there isn't any really good way to weigh that. But you can weigh what you had before, and you can weigh the amount of mercury you had afterwards. So the mass goes down, and the amount that the mass goes down is equal to the amount of oxygen you have in this reaction. So it turns out it's pretty simple to get the oxygen, in this case, just by subtracting the amount you originally had and the amount that you ended up with. Now, from here we want to somehow determine from this information how many atoms of mercury and how many atoms of oxygen are in the compound. Now, it turns out that it's a little less work to figure out the number of atoms. You can figure out the number of moles, and the ratio works out to be exactly the same. It's a little less work, and so instead of figuring out atoms of mercury and oxygen, we're going to just determine the number of moles of mercury and oxygen in this compound. So you do this the way we always do. Start out with your grams of mercury, divide that by the molar mass of the mercury, and this will get you your moles of mercury. You do exactly the same thing, starting out with your grams of oxygen, divide that by the molar mass of the oxygen, and you'll get your moles of oxygen as well. So now I'm going to stop it right here for a second and just say that I'm rounding off those molar masses quite a bit just because it's easier to present here, and but if you're doing out these problems and you're in a lab or something like that, you really don't want to do that and can kind of mess up your ratios. So again, I'm rounding off, but just be aware that that's probably not a good idea. In any case, this problem works out to be pretty simple, and the ratios you can see right off the bat are 1 to 1. 1 mole of mercury to 1 mole of oxygen. And we simplify that down to a 1 to 1 ratio, and that tells us that the formula is HGO. We typically don't write those subscripts. We just leave those blank when it's just 1. And so the formula, again, is just HGO, which would be called mercury 2 oxide. So that's an example of how to determine the empirical formula given the grams of the compound, and I hope that helps.